Okay, it's finally happening. It's been announced that Peregrine will be flying to the moon no earlier than May 5th, 2023, on board the Vulcan rocket on its inaugural flight. I am so excited. And I thought this was a great opportunity for us to regroup on the mission and talk to somebody who's really close to the ins and outs of the flight to get us up to speed on what we're to expect with the mission. Now, obviously, this flight is a really big part of this channel's DNA with the I Need More Moon mission that we delivered nearly 2 years ago. So I'm very excited to introduce Shrad Baksharan, who's the mission director at Astrobotic of the Peregrine Mission. He's got over 30 years of spaceflight experience sending all kinds of stuff to space, involving such programs as the Space Shuttle, the Mir Space Station, the International Space Station, and that's just really only naming a few. In this interview, we're going to cover a lot of ins and outs of the flight, in particular, what it's like to start up a space startup, but not just like a space startup, but a lunar landing space startup, which has its own particular hurdles, we'll just say, to get going. You're going to learn a lot about the business of space, just in general. So it was a really great, engaging conversation. I hope you guys enjoy it, and let's get into it. Shrad, thanks a lot for joining us today.
Thank you. Always like doing these kind of conversations, having these conversations and talking about what we're doing and talking to folks like you. So thank you for the invite.
So you're the mission director. Would you mind just explaining to my viewers, what does your job entail in particular with this mission of Peregrine?
Mission director is kind of a unique title we developed here at Astrobotic. It really is a program manager is what I am. So I'm responsible for the overall program, the mission, the cost, the schedule, the risk profile, overall technical performance. So ultimately, it's my responsibility to make sure that the mission is successful. But that said, obviously, I have a very large team supporting me and that does all the detailed engineering. But ultimately, I'm a project manager, program manager. That those terms are somewhat used interchangeably. But a mission director is a formal title I have here at Astrobotic.
Gotcha. Now, being this is the first flight of Peregrine, are there anything more intrinsically challenging about being a mission director for a maiden voyage, essentially, of a lander?
Absolutely. And the challenges more have to do with the fact that, when I came here in 2016, we were still a small company, a startup, and only had 16 people at the company. We had some partners helping us along, but when you have to build everything from the ground up to do a lunar landing on the first attempt, that's quite ambitious. It's not like being a company where all the infrastructure, the tools, the processes, the people already there in place, and you're starting a new program. We're starting everything here from the ground up, and that makes it definitely more challenging. But inherently, spaceflight is challenging regardless of what you're doing in space, and so this getting to land on the moon is inherently challenging, whether you're doing it here or at a large company.
Granted, it is uncrewed. It's still very challenging to do this, and it's not something that we've done at all recently. So obviously technology has evolved greatly. There's some of the basic elements of a lunar lander that carry over even from 50 years ago in terms of what you need to do. But in your mind, what are some of the largest differences between what we're seeing with Peregrine and what we may have even seen with the Apollo program with their lunar lander, which obviously had people in the loop, it was a little bit of a different system, but what are some of the more stark differences you see with this lander compared to its predecessors?
Yeah, as you pointed out, this is a robotic lander, not a human crewed lander. So there's an inherent difference there. But I would say the biggest difference is something you can't really see, which is computing power. The processing speed, the storage space, and the memory. It's evolved dramatically since the Apollo days. And so what that does give you is a lot more computing power. Also, to some degree, it's also the miniaturization of that computing power and the other technologies that go with it, the sensors, all the instruments you have to have on board the vehicle to guide the spacecraft, to land it. They've evolved dramatically in 50 years. And part of that is also not just the performance of those instruments and components, but also the size and the weight. The more you can miniaturize and the more you can minimize the mass of these components, the more you have capacity to add payloads to the vehicle, which is the whole purpose is the more payloads you can deliver, the more science you can get, and the more customers you can support on a single mission. So it really is a combination of, again, the computing power, being able to develop these technologies in smaller boxes and chassis and enabling then a greater capacity to fly payloads, which again, like I said, ultimately these missions are to do science and to do technology demonstrations. So the more you have room and capacity to do that, the more valuable these missions are to the customers.
When it gets to the moon on its landing attempt, does it have the opportunity to kind of loiter at the moon until you guys are feeling really confident about the landing, or have that really dialed in, the landing site and things of that nature, or abort modes? How much is the ground interacting with the lander during the flight and down to the surface, hopefully?
Yeah, when we get into lunar orbit, there are definitely uh, phases of that mission, that part of the mission where we do checkouts of the instruments that we need to do landing. And so we'll do the necessary calibrations. We'll, again, check the performance of all those so that when we actually approach the final descent trajectory, we have high confidence that all the sensors and all those instruments will operate as we planned. So there is that kind of checkout time in orbit before we do that. We don't want to, we don't want to try to rush it and not have the confidence in the final approach.
And how does it feel to you personally to be the mission director of this landing? I mean, I don't want to speak for you, but I feel like it'd be almost a career highlight for me to be able to have the opportunity to even work on a flight like this.
So my entire career has been in the space industry, and so for someone like me who's been in various management roles before this, being given the keys to a lunar lander is a tremendous opportunity, and nothing I would have been crazy, honestly, to pass this up. I mean, this is not just the fact that it's a lunar lander, but it's also we're attempting to be the first commercial company to land a spacecraft on a planetary body. That adds to the intrigue and the excitement about doing something like this. So I feel incredibly lucky to be in this position, to be perfectly honest.
Now, in developing this lander, like we've mentioned several times, it's a first of its kind in many different ways. In your mind, what was the largest challenge to overcome with actually getting this thing to work properly?
As I kind of mentioned before, we started designing the lander as we were also building a company. And so when you take those two and you try to build the infrastructure and the processes, your staffing up to meet the needs of a complex program, that adds a lot of complexity and a lot of challenges. Where, again, if I were at a big company that were all that had already existed, you would focus more on challenges that are probably technical in nature. But here it's getting the right amount of funding, being able to purchase and acquire the tools necessary, both software tools, simulation tools, analysis tools, all the tools you need to build a lander and to test components of the lander. We had to do all that from scratch, and it took a tremendous effort by the team and the company to be able to make those elements of a successful lander program come together as the lander itself is also being designed and built, and all the, again, analysis that goes along with that. That's a heavy load to carry, and a tremendous challenge for the entire company, really, to do that. It's an evolving process. The more you the more you design, or the more you analyze, the more you simulate, the more you model, and then transition into the build and test, you're buying down risk during the whole process. And so the more you test, the more confidence you have in the mission. Early on, when it's a paper concept, you don't really know if when you start building and testing, it's all going to work out. It's all based on, again, simulations and analyses. So the confidence is gained over time, which is, again, the way engineering is. You have to build and test, and you have to have confidence in testing, because, as you know, once you put a spacecraft on the launch vehicle, you don't touch it again. You can't just for most spacecraft, there are obviously space station being the example
Cargo load,
you can't actually provide maintenance, routine maintenance on. But for us, once we get on the launch vehicle, after that we can do some software uploads, and we can, of course, command the spacecraft. But if a component has a problem, if something came loose during launch, we can't go up and we can't go up and fix it, which is why we test to simulate those environments as rigorously as possible. Vibration testing, thermal vac testing, EMI testing, all that, and try to subject the spacecraft to extreme environments, the extremes of those environments, to make sure that it does operate in space. So again, spaceflight inherently, as I said before, is challenging for anybody. But these are some of the bigger challenges we had as a company to do this. But we do, again, it's a world of difference to be at the stage we're at right now after having gone through a lot of testing and having confidence that our spacecraft could actually function and carry out its mission than it is when you have a bunch of designs and analyses products.
This mission was originally slated to fly in the summer of 2021, but there was a variety of challenges. Obviously, the pandemic happened that bottlenecked every industry on the planet. But outside of that, there was also Vulcan had its own, delays with its development. So it's actually kind of magical to kind of see them both systems coming together here now at an apex, all things considered. Do you see on future flights of either Peregrine or Griffin that because you guys have gone through this harder yards of building the business and the levers to actually do this, that it should hopefully be a more of a streamlined or smoother process moving forward?
We have learned a tremendous amount going through the Peregrine program, and many of the lessons learned we are already implementing on the Griffin program because of the stage of the program, stage that program is in. So, in some ways, I think I feel some of the I feel some of the financial strain and some of the schedule strain of going through the first time, whereas the second program, third program, will have all that to leverage and to not make the same mistakes. But that's the whole process. You learn from your mistakes. You learn from things that maybe were done inefficiently. You learn from maybe selecting the wrong component the first time around, and you go to select a different one. So the maiden voyage, the maiden mission, always is going to have those those issues where, oh, why did we do that? We should have done this. Well, you can't. It's too late to make the change on Peregrine, but certainly we have already, like I said, implemented many changes on our subsequent programs to ensure that we didn't make the same mistake again. And if we found a way to do something more efficiently, more cost effectively, shorter schedule, then we certainly implemented those for our second program.
Looking back at the predecessors of Peregrine, both the crewed and uncrewed lunar landers, were any lessons or designs or any influence from those landers taken into account when developing Peregrine, or was it a clean sheet type lander? I'm curious if looking back at that history, if that helped, there were lessons there that carried over to this lander.
Yeah, I'm not sure you're referring to like the previous American missions, Apollo, Surveyor, or if you're talking about the more recent.
I was considering more Surveyor or Apollo, but I know that the Chinese did land on the far side with their lander and rover. But even them, like, I'm curious to hear what other landers, not even lunar, but just landers were taken into account when it came into this design process.
Interestingly enough, we did actually resurrect and look at papers that were written post Apollo and Surveyor because they're relevant to some of the challenges you face trying to land a spacecraft on the moon. More recently, I would say that the missions that have attempted lunar landings, if the information is made public, we certainly have read that and absorbed it and made sure that we are not making the same mistakes. Just like the Griffin mission benefits from Peregrine's learning and lessons learned. We similarly, where information is shared, we certainly look at it and try to ensure that we don't make that same mistake. But yeah, early on we did do a lot of studies on previous missions, even spacecraft that didn't go to the moon necessarily, to understand what we could do, what we could incorporate, and make sure that we have the highest probability of success. This is a big year for lunar landings and lunar missions in general. So it's going to be, iSpace has already launched, and they're supposed to land sometime in April. So there's quite a few missions going to the moon, and we're going to be watching very closely all of them, and hopefully they're all watching us too, because the more success, the better, ultimately.
Yeah. Several of my viewers did participate in what I call the I Need More Moon project, putting, several thousand names on a piece of silicate and tens of thousands of names on an SD card, as well as family photos, memories, all kinds of great stuff. And it was put inside of Moonbox, which is one of the payloads on your lander. Would you be able to tell us, where is the Moonbox like mounted? What kind of material is it made of? Is there any kind of protection? Just kind of curious what you can tell us about where that ended up.
Yeah, I can tell you about the container itself. It is, so we have two payload decks on opposite sides of the spacecraft, and that's where the majority of our NASA and commercial payloads are mounted. And so Moonbox is on the underside of one of those decks, and it is an aluminum container, and it's sealed. So in some ways, I guess, since it's underneath the spacecraft, not on top, less exposed to some of the elements. But yeah, I mean, we designed it to be to certainly survive all the environments of the mission itself, and to be on the lander for a long time after the lander is decommissioned.
No, that's great. Yeah, hopefully it's more in the shade or than not, because I think people are hoping to go visit it one day. Are you, I guess, first of all, expecting to see anything from the Lunar Reconnaissance Orbiter? I know this is a small lander, and even the Apollo landing sites are pretty hard to discern. Are you aware of any kind of imagery from orbit we could potentially see of the landing site?
Yeah, so we have we actually started talking to the LRO folks a few years ago, and they they're fully supportive of these imaging these all these lunar landers. If you remember, they did actually take an image of the landing site where I think it was Space IL attempted landing, and so they did image that. Unfortunately, it was not a successful landing. But yeah, we certainly are going to be working with LRO when we have more definitive information on our landing time, and then can share that with LRO to see when they can make a pass over the landing site, and hopefully take a nice image of the spacecraft and the solar panel on the top. So yeah, we're absolutely working, planning to do that.
That's great. And in terms of communicating with the lander, I'm assuming you'd be utilizing like the Deep Space Network to make those comms?
That's correct. We have a commercial agreement with NASA JPL to use the DSN 3 in Canberra, Madrid, and Goldstone, California. So that'll be the network that we're using from separation all the way to through surface operations.
Onboard cameras. Are there any? How many are there? What can we expect to see from the lander? Because I think people, I know myself personally, I would love to see the perspective of Peregrine, obviously on descent, but where it is once it gets to the moon.
So we do have multiple cameras, HD cameras that have video capability as well. We don't have any customer requirements necessarily for video, but we certainly plan on exercising all our options as far as imagery and video when we can, and certainly post-landing, because we want to verify landing not just through our sensors but also through imagery itself, and then any payload customers that have a requirement, to have an image of their payload after landing, obviously we will provide that to them as well. So that's all. Those are all written into the contracts.
So in terms of public consumption, it's not a priority. It may happen if things all work out as we hope. Do you know where the cameras are located on the lander?
We position them based on two things. Based on if a payload customer had a requirement to, again, image them with the horizon, the moon horizon in the background, that we certainly want to capture that. If they had a different angle they wanted, we made sure we captured that. So we work with them to make sure that whatever angle they wanted is where we put the camera. But we also position cameras for ourselves, again, to take an image of the horizon, perhaps an image of, kind of showing where we're at. So yeah, two drivers for how we position our cameras.
So I guess we can't necessarily expect any kind of live stream experience. It would be something that would be captured locally and then sent back for you guys to the DSN.
Yeah, correct. We don't have the bandwidth to do live streaming.
I know it's a challenge, and I think a lot of people even learn that with the the Artemis program. It had a pretty narrow pipe, and even folks at NASA were surprised at how much they were getting. Things were just seemingly going so smooth. So I'm hoping for the same level of smoothness for you guys. How long are you all expecting to operate Peregrine on the surface of the moon?
1 lunar day. So it equates to about somewhere between 8 and 10 Earth days. And so we will land sometime after local sunrise at our landing site. After we do the checkouts of the spacecraft, then we'll start the process of operating payloads, and that'll proceed and go on through lunar high noon, lunar noon, and then all the way to close to dusk. And after that point in time, we'll cease operations, planned operations.
Curious if you think that Peregrine will survive lunar night, and if so, is she programmed to phone home if she does wake up that first time?
Peregrine is the first lander is not designed to survive lunar night. Certainly, that is a technology that we're looking to incorporate into future landers, because clearly, to support the science community, we need multi-day operations, and so we're certainly looking at technologies to do that. But Peregrine really, again, is about successfully landing, soft landing on the surface, and demonstrating payload services. So once you prove that, then you can go on to the business of evolving lander, evolving the capabilities and the services we can provide to our customers. We didn't design it to survive the night. We will probably make an attempt during the next day, lunar day, to ping the spacecraft and see if we get a pulse. But it's not a mission requirement.
Would you mind just briefly just explaining why surviving lunar night is such a challenge?
Yeah, the extreme cold temperatures. There is no atmosphere on the moon, so there's no way to. The temperature or the sun exposure is going to be extremely cold at nighttime, and then of course during the daytime it's extremely hot. So at nighttime it's going to get to cryogenic temperatures, and that means that the electronics and the spacecraft in general can't survive. They're not designed to survive those temperatures without active heating or even passive heating. Since we didn't design that into the spacecraft, we're not expecting those components to survive the lunar night.
One of the reasons where the Mars rovers, considering they have their own little mini nuclear reactors on board, they have seemingly unlimited power to be able to keep things warm when they don't need to be, and that's why we've unfortunately lost a few Mars rovers due to sandstorms and things of that nature, because they couldn't stay warm.
I can't reiterate enough that this is about proving that really this first mission is about proving that a commercial company can land a spacecraft on the moon. We're not a NASA mission. We don't have NASA engineering and NASA support. We are truly a private company trying to do this, as are some of the other private companies as well. We're trying to do this at a much lower cost than the typical government missions, whether it's NASA or another space agency. We're doing it. We're trying to do it much lower cost. So it's a game changer, in my opinion, if we succeed. But that's why I'm not going to say the bar is low, but the bar is about landing safely.
And I don't know if I'd call it low, because you're landing on the moon. So I want to cut you some slack. And by no means am I trying to give off any perceptions like, oh man, you're not going to survive lunar night. Like that's like nobody's done that. That's by no means am I trying to make any kind of impression. It's just more of innate curiosity on my part and others' parts, because so many are excited about this flight and obviously want it to last forever. Is there anything that you are personally looking forward to learning at the end of this mission, or even seeing? I'm always curious when people are so close to these missions. There's so much nitty gritty that you guys are just trying to get through. But at the end, is there anything in particular that you're looking forward to learning about the most?
What I want to learn is whether the commercial company can do this at the price point we're talking about, because that's what attracted me to this whole idea, was the fact that no one's done this before. And while people will say, well, of course we landed on the moon 50 years ago, and we landed humans on the moon 50 years ago, which is a phenomenal achievement. For us to do this, I think it's also, again, a commercial company doing this, procuring all their own equipment and supplies and staffing and starting from the ground up. If that ends up in a lunar landing on the first attempt, I mean, that proves a lot. and it really opens. I think it, in my mind, it opens up the solar system for more commercial activity of this kind, because then we've proven it can be done, and that's a pretty significant, in my mind, a pretty significant achievement.
So the landing site was recently announced to have been changed. It was originally planned to be Lacus Mortis. You're looking at the moon. It's like the very northeast type region, if I remember correctly, of the moon. But it has been since changed to, and I'm going to absolutely butcher this, everybody, Gruthchen domes.
I think we all pronounce it incorrectly, but I call it the Gruthheisen domes. I think that's maybe close.
Gruthheisen domes. I like that one. That's a more fun way of saying it, at least.
I think we're all butchering it.
Hi TJ, hi Sharad. I just saw you suffer with this name, and since I am from Germany, let me correct you there with the pronunciation. It is called Gruthhuisen domes. And now, how do I get out of this video again?
Are you expecting any particular differences in the terrain? Is that now something else that you have to plan for, or was Peregrine game for all of this?
No, we had to do the same analysis, landing site analysis for this region that we did for Lacus Mortis. Mainly to make sure that, first of all, our lander was designed to be able to land at this location, that the slopes in this region, the boulder sizes were similar to what we saw at Lacus Mortis, because frankly, by the time this request was made, it was really too late to make major changes to the lander itself. So we had to go through that same process, do a thorough analysis, and confirm that yes, we could. The conditions are basically the same, and the spacecraft doesn't have to be modified in order to make this transition.
Are you aware of, or can you say what made this landing site more ideal for NASA versus Lacus Mortis?
As I understand, there's an instrument flying on a future mission. What we're flying on our mission, some of the instruments will gather data that they can use to compare against the future mission is what their motivation was. So it was really a science-driven request, and we're all about supporting the science community. So once we confirmed we could do this, yeah, it absolutely made sense to pivot.
This new landing spot now for looking at the moon, it's more, if I'm remembering correctly, it's now, if I'm looking at it, it's like the northwestern quadrant of the moon, maybe closer to the equator, if I'm remembering right.
That's correct. Yep.
We can all stare at that spot together. We're just looking all at a new spot. Once you guys have touched down, will you guys be able to publish like exactly where this lander is going to be?
Yeah, in fact, it is a requirement that we provide that to all our customers so they know actually where we landed. So I wouldn't see any reason why this wouldn't be publicized to the general public at some point.
I don't think anybody's going up there to steal it, so not at least anytime soon. As far as you know, is there any technology or perhaps early technology that's flying on Peregrine that will be later utilized in the Artemis human landing system?
I know that we're flying instruments for NASA that they want to potentially use on future missions and Artemis missions, I think. But I'm not the expert to speak to that. It'd be someone more involved in Artemis that would speak to that. But this is, we do have a large suite of instruments on this mission, and the whole idea was to exercise those instruments and gather data, for future Artemis programs. And again, to prove we can do this. That's really the fundamental goal here.
Not to show preference for any particular customer, but is there an instrument on board that you find the most interesting?
One of our commercial payloads is from the Mexican Space Agency, and it looks like, I can best describe it as, it looks like a bread box. But once we land, it'll open up and deploy some mini rovers onto the surface. And I think the whole idea of this experiment is to kind of communicate with each other and back to the chassis. So they've been with us for quite a while. And I think it's a fascinating little experiment, and I'm really rooting for that one to succeed. As all of them, I'm rooting for all of them to succeed. But that one's the one that I kind of really thought was a really cool idea and very innovative.
Oh, naturally. And yeah, that's a great reminder that Peregrine is a lander, but there's also rover components to it. Is there another rover involved with the lander, or are those the only ones?
No, we have the Carnegie Mellon Iris rover is also flying with us. Yeah, so that'll again also deploy after landing, and it'll traverse some distance and send back images. And and science data.
I keep knocking on wood here. I'm not sure what your superstitions are, but if all goes well, we may have some great shots of Peregrine on the surface from one of these little guys.
That would be really cool. But really, to me, just confirming, post landing, if we get that image of the horizon with one of the Peregrine decks or maybe the tank or whatever, kind of on the side, I think that's to me that would be. It would be quite a moment for us as a company.
It would be hard for me not to blow it up into like a 6-foot wide photo to hang on a wall somewhere. Beyond this flight of Peregrine, I know that there was desire at some point to do more flights of Peregrine. Are you guys working on another lander? Is there another one on the horizon here? Or are we still just trying to get through this flight first?
Obviously, my main focus is to get through this flight, but as a company, we're looking at other opportunities for the Peregrine lander. Once we have a successful mission, obviously, we'd like to demonstrate we can, or we'd like to use it again, because then it's a proven platform. It's what we call, TRL-9 as a vehicle. So we are looking at all sorts of opportunities, commercial and government, to see if we can use that lander again. But we also, of course, have our second lander, Griffin lander, in development already. So we've got 2 product lines that we're trying to market for many different customers.
And for those who aren't aware, Griffin is a much larger lander with additional capabilities, but depending on the customer, depending on where you're going, variety of reasons, Peregrine might be the better home for what you're trying to do versus Griffin. So it's nice to see multiple offerings depending on what people need. Beyond this flight, are you guys thinking that Vulcan will still be the booster for Peregrine, or is that still yet to be seen?
When we start developing a concept for a new mission, that's when we have to figure out what performance do we need, first of all, from a launch vehicle. And then we go through a whole process of doing trade studies on the different options and available platforms to do that. So, it's a long process, but it really involves what is the mission requirement? What are we trying to do with the mission, and where do we need to go? And from there, there has to be a trade study done on the different options available to us. Prices obviously is factored into that as well. So yeah, it'll be based on mission requirements.
The world we're living in right now is Vulcan is currently at the Cape, undergoing some final integration, and it'll go through a test regimen, static fire, things of that nature, so it's still got some work ahead of it. In terms of Peregrine, I know the lander's back home with you guys in Pittsburgh. Is there anything else that needs to be done to the lander before it gets shipped to Kennedy? Are there any more components or testing that needs to be done before it goes off to for its final trip?
Yeah, we do have the engines to integrate, the axle engines, and we always plan on doing that down at Kennedy. In fact, we'd already coordinated with the folks down there to do that. But that is pretty much the last step. There's some final testing we're doing, some troubleshooting we're doing here and there. But other than that, we're ready to go down to Kennedy and integrate those engines, and then go through the next steps to load the propellant and everything else we do as far as our pre-integration processing with ULA steps. So
where we're at in the process now is waiting for Vulcan to be ready before ULA, and then ULA can say, all right, thumbs up, come down, and you guys get to work. Is that kind of like where we're at right now in the timeline of things?
I think we're really waiting for ULA to tell us when to ship Peregrine down there, because again, there's no point in shipping it too early. There's a sequence of activities that have to happen. It's ideal to do that when everything is known, and rather than spend unnecessary time down there. So we're just waiting on them to tell us and when to go down and again complete the activities I just mentioned.
Well, I'm very excited, Sherrod. Is there anything else that you wanted to cover in our conversation this afternoon, or maybe anything you want people to know before they see this exciting mission happen?
Again, as I said, this is an historic mission. If we stick this landing, it's for so many reasons, not just again landing a commercial vehicle on the surface of the moon, but to do it when we started this as a 16-person company, and then to achieve what we've done today is a remarkable testament to the work ethic and the capability of the team we have here in all aspects of engineering and operations and everything. I hope people are paying attention. I hope people realize what this next wave, next generation of lunar missions is all about. It's about changing from more government missions to more commercial missions, and that has incredible ramifications for the future of commercial space flight, the future of exploration of the solar system. It's a stepping stone, I think, and I hope I hope other companies are successful as well, because that makes it all the more feasible for other companies and other entrepreneurs to think about doing something like this in a similar fashion.
That was great. And Sharad, I want to personally thank you and everybody at Astrobotic for giving somebody like me and so many other people an opportunity to participate in such a historic mission, regardless of how this goes. I'm incredibly proud to have been part of this process. And I know myself and many others who are in the space communicator wheelhouse on the internet and other places are going to do their best to make sure the world knows about this flight when the time comes, and let everybody know the impact that this flight will have on the business of going to the moon, the literal business. And it's really the first of hopefully thousands of future missions to the surface with and without people that we can all look forward to. So thank you so much for your time today. This has really been great. And I really do hope that we talk soon, because I know that you guys have a lot of other exciting things to talk about.
Well, and thank you for putting the spotlight on us and illuminating all these different things that we're doing in space, because it's really exciting. So thanks for doing what you do as well.
I want to give a special thank you to Astrobotic for helping facilitate this great conversation with Sharad. I know I learned a ton. I also want to give a special shout out to Felix from What About It for teaching us all how to pronounce Gruithuisen domes. I think that's how you say it. Probably butchered it again. I don't know. I'll probably never get it right. I'll practice. I promise. Go find his channel. Check it out. Find it on YouTube. It's called What About It. It's great weekly space updates. I'm sure everybody watching this channel is aware of Felix, but I'll put a link in the description so you can find it. And this is where I beg, if you like the video, subscribe. I would really appreciate it. These type of videos take a lot of effort, as you can imagine. I'm not gonna lie, this flight is gonna be really an emotional one for me. You know, this is several years in the making, at least for the I Need More Moon project, finally coming to fruition, seeing our baby fly. You know, tens of thousands of names and photos and stories, and just so many incredible special mementos that people from all over the globe sent to me to help provide to Astrobotic to get to the moon. So it's really special. I'm very excited, and hopefully it gets down to the surface in one piece. Cross my fingers. So thanks a lot for watching. I hope you learned something new today, and I'll catch you guys later. All right, bye.